In this video, we will solve GATE 2021 ECE problems. In the first question, they have given a question based on PMOS MOSFET, and it includes channel length modulation. It includes CLM, that means it has RO1 and RO2. So before going to solve this problem, I will just revise the MOSFET model for PMOS. For PMOS, let us consider source, drain, and gate. The small signal equivalent is the current will flow from source to drain, and the value of current is GM/VSG. This is source terminal, this is drain terminal, this is gate terminal, this is VSG. If channel length modulation exists, there will be a output resistance of R0 or RDS. The output resistance will be from source to drain. It will be connected between source and drain. So for a simple configuration, for a feedback from gate to drain, Rn, we'll find Rn. So what I'll do, I will copy the equivalent circuit of this. Let us say this is grounded. If I apply a test voltage of Vt here, Vt, and the current is It. So VSG here will be, since Vg is grounded, VSG is Vt. This is also grounded. These two are connected. So It is Gm times of VSG is Vt, Gm Vt, plus the current flowing in this branch is Vt by R0. Vt by R0. So if I take Vt common, it will be Gm plus 1 by R0. So Rn is Vt by It 1 by 1 by Gm plus 1 by R0. If we rewrite this, we will get 1 by Gm parallel R0. So the equivalent resistance looking from the source is 1 by Gm parallel R0. So when we come to this question, this is like connecting gate and drain together. So I can simply write this as M2, and I can write the looking down resistance as 1 by Gm1 in parallel with RO1. This is ground. VDD will become ground, and I have told you that we'll connect a small signal resistance from drain to source if channel length modulation exists. So the resistance from this node to ground will be RO2 on the top side. RO2 Vin. So now this become a similar circuit we know, the simple CS amplifier. of PMOS. So we know that for CS amplifier the gain is minus GM RD. Here the GM of the stage is from GM2 minus GM2 into the load resistance here is RO2 parallel 1 by GM1 parallel RO1. So the small signal gain is S1 minus GM2. So the small signal gain is minus GM2 into 1 by GM1 parallel RO1 parallel RO2. So we'll go to next question. Here it is given that we have applied a pulse input to the circuit and the on time of the pulse is 1 millisecond and the off time of the pulse is 1 microsecond. Here the basic thing to note is what we'll think at t is equals to 0, t is equals to 0, the frequency content omega is infinity. So ZC is 1 by j omega c, impedance of capacitor. This will become 0. That means the capacitor will become short circuit at t is equals to 0. So the equivalent circuit will become like this. This is 10 volts and we have a R, we have a diode here. Since Vp, I'll call it Vp and this one as Vn. So since here diode is forward biased, so when the diode is forward biased, the resistance offered by the diode is 0. So this will be a short circuit. So no current will flow through this resistor. The current will be 0 here. So throughout the on period of the cycle, V0 will be 0 volts. We should not think that capacitor becomes capacitor is short circuit at t is equals to 0, and we should not think that the equivalent circuit will be like this and it will charge and V0 will reach to 10 volts. This is wrong because we have a diode here. Since the diode is there, it will offer a low resistance path if this node potential is greater than 0, so it will become a short circuit and 10 volts will be here and this will become 0 volts. So the voltage across capacitor is 10 volts. So in the positive half cycle, V0 will be 0. For t on, diode is on and V0 will be 0. For t off, we have Vs as 0 volts and we can replace it with a short circuit. At t is equals to t off, the instant where the input voltage goes from 10 to 0 volts, the output voltage will become minus, it will become minus 10 volts since the polarity got reversed. This is V0. V0 will be minus 10 volts. So from minus 10 volts to 0 volts it will discharge. So in the question they have asked V0 max minus V0 min. The maximum voltage at output is 0 volts and the minimum voltage at output is minus 10 volts. So the difference is plus 10 volts. Plus 10 volts is the answer. And here this op-amp based question, they are asking the condition at which Vout equals to 0. This is Vout. Let us say Vout is 0 volts. Since the circuit is in negative feedback, this will follow virtual short condition. So this will become 0 volts. So no current is flowing here, 0 amps. No current is flowing here, 0 amps. So this node potential, let us call Vn. This has to be 0. Vn has to be 0. So Vn is given by, if we apply superposition theorem, if Vn alone is active, Vn V in, if V in this voltage source itself is active and this is not active, Vn will become Vn by 2. And when Vref is active, and this is not active, this is short circuited, then Vn will become minus Vref by 2. For this to be 0 volts, Vn should be Vref. Vn should be Vref. The answer is A. In this question, they have given all of the information. They have given mu1 Cx as 100 micro, WL as 10, and VGS of the transistor as 1 volt. VGS is applied as 1 volt, and they are asking us to find out the threshold voltage Vt when M1 is in edge of saturation. So we know that for NMOS, we know Vd is Vg minus Vt for saturation. That is, Vd can go 1 Vt below Vg. So here Vg is 1 volt, and we have to find out Vt. We don't know Vt, so that we'll assume this as Vt. Vd is 1 minus Vt. So let us assume the current flowing is I. 1 minus Vt is 3 minus 20k into I. And we know that the in saturation I is half mu1 Cx W by L into Vgs minus Vt the whole square. If I plug the values, mu1 Cx is 100 micro, W by L is 10, Vgs is 1 volt, and Vt is Vt. So if I simplify the above expression, I will be, if I bring this 20k into I this side and 1 minus V2 to the other side, it will be 2 plus Vt. If I bring 20k down, I will be 2 plus Vt by 10. I will equate the current with this expression 2 plus Vt by 20k, and the current is half into 100 micro into 10 is 1000 micro, which is 1 milli. So it will be 2 plus Vt by 10, 2 it will go 10 times, and k will multiply with 1 milli here, so it will become simply 1 plus Vt square minus 2 Vt. So we will get a quadratic equation, 10 minus Vt square minus 21 Vt plus 8. If we solve, we will get two solutions. One is 1.6 and the other one is 0.5. 1.6 cannot be the answer, 0.5 is the answer, because if it is 1.6, the MOSFET will not turn on because VGS is 1 volt. So the answer is 0.5 volts. On the last question, a pulse wane of 20 millisecond duration is applied. The capacitors are initially uncharged, so I'll replace it with a single capacitance of 2 microfarad. They are in parallel. Positive V side is plus 12, negative V side is minus 12 volts. And V in is applied, and again they are asking at t is equals to 0 plus. At t is equals to 0, omega here is infinity, so ZC is 1 by j omega c. So the equivalent impedance is 0 ohms. So effectively this is a short circuit. This will become a short circuit. So at t is equals to 0, it will be 5 volts and this is connected to ground. Since Vn is greater than Vp, the output voltage V0 will be negative Vsat. Here negative Vsat is minus 12 volts. So at t is equal to 0 plus, the output voltage is minus 12 volts. That's it. Thank you.